Hey, I'm David Baszucki, CEO and founder of Roblox, and today you're listening to Tech Talks. I'm here today with Kiran, Bhat, and Nishchaie, Khanna, and we're talking everything AI at Roblox. We're going to go through a history of AI. We're going to talk about the systems that we've been running starting in safety over the last 4 years, and then we're going to be jumping to the future of AI, generative AI, creating 3D objects, based on just whatever you could imagine and where it's going at Roblox. Thanks for joining us. Welcome, Kiran. Welcome, Nishchaie.
Thanks for having us, Dave.
Thank you.
Okay, so, I was doing a little mental calibration recently of sci-fi, and I used to read a lot of sci-fi when I was a kid. The Dick Tracy watch has come true. The interweb running around not using a credit card has come true. The holodeck, in a little bit of a way, Roblox starting to get there, right? 3D, faster than light travel, not so sure. We'll see if that ever happens. But then robots and AI, HAL Computer, 2001, movie was built in 1969. Like, we're getting pretty close, aren't we?
We are.
Like the red dot that you talk to?
That's right.
Okay.
All the natural language, speech understanding, taking that to an actual brain and then producing outputs that make sense.
Yeah, so we saw that movie. We saw chess with Deep Blue, the first time chess ever beat a human.
Correct.
Would you call that AI or early ML? How would you all think of that?
That would be even early search-driven systems.
So we're not going to give that an AI?
Not quite there yet. Yeah.
Okay.
Very early. I mean, I think maybe you should call it the traditional AI, the classic AI approaches.
Okay. Then there was a time when IBM Watson beat some humans at Jeopardy. That seems like a fairly long time ago. AI or not AI?
Getting towards there.
Yeah.
Building on top of classical AI.
We would probably call that classical AI.
Classical AI. Okay.
Maybe the state of the art of classic AI.
Fast forward behind the scenes at Roblox. I don't know if many people know it, but 3 or 4 years ago, probably 8 years ago, everything in trust and safety was predominantly human. We had to review every image, every sound, every moderation action. And I know we started talking about using this thing called BERT. ML or AI? What would you say?
I think that category is the early days of the modern AI, transformers based. So I think that's the big jump from the rule-based systems to neural network-based AI, and transformers came to prominence with BERT.
Okay, so behind the scenes, we're using that. You both work on a lot of deep technical platform, and then your company that came on board with Roblox to help track faces and transmit that in animation, Lumi, right?
Yeah, that's right.
AI or not AI?
I think I would call that ML.
Okay.
It's computer vision, neural network based, CNNs, very small models that run on your device. So it's the previous generation of custom models that work really well on a given problem, and it's very fine-tuned for that problem, but nothing beyond that, right?
Okay. And so fast forward now, the world's changing so rapidly. One of the reasons we were talking earlier that this is such a special episode, everyone out there, we are living in the middle of the sci-fi book, right? Like 2 to 3 years ago, no one knew what ChatGPT was. Today, we're all debating whether to search for links or search for answers. Do you all feel we're living in the middle? Like, is this the most radical time of change ever?
100%. The world's changing every week sometimes, with a new model being dropped, a new technique being invented, or things running more efficiently. It's a great time to be alive.
Yeah, and I think the other thing is the pace of innovation and the energy that's put into AI has also seen a dramatic change since ChatGPT. And so you see big new drops from all different players, open source, big companies, which move the needle forward in how we understand the space, and the capabilities that come almost at a weekly, monthly cadence is inspiring.
Do you think that's also healthy in a way? Because you remember a year or two when we could all have a command line, we could have a Chat GPT command line, and everyone was blown away. When you talk about a drop now, what I interpret that is, let's go through it, right? Grok, Google, Gemini, DeepSeek, Microsoft, Mistral, ChatGPT, OpenAI. What I interpret these drops as is starting to show that many different companies can build this technology. And when you say it's a week apart, it feels to me like many, many companies are pushing at this at the same time. Is that a fair way to think of that?
That's an incredibly fair way to capture that idea. It's like a lot of people trying, to work on the space and building on top of each other's ideas. The incredible thing about this wave has been the sharing of ideas, open sharing of code, weights. So people can build on top of other intuitions that are the best intuitions that are out there. Because going back to one of your previous points about ML versus AI, the big difference now with these larger models is how general purpose they've become. Yeah. And with these general purpose models, you want a lot of people to be working on different facets of the problem and unlocking pieces of the puzzle, which helps the community at large.
And I think it's healthy competition. If there was one player, we would not see so much innovation. The fact that it's so many is pushing each other to improve on benchmarks, get to reasoning quicker, get to creation quicker.
There's maybe some notion that because a lot of this is in software and a lot of it is in computer science, what we got used to in maybe between 1915 and 1940 in the automotive industry, which happened arguably over 40 or 50 years, you think about the V8 engines, seat belts, better materials for tires, automatic ignition timing, carburetor, all of that stuff. We're kind of seeing a compression of that. And, rather than these innovations happening yearly, it sounds like literally seeing them weekly or bi-weekly.
Yeah. I think this is the artificial intelligence revolution.
A couple thoughts. One, just a random thing, because we're gonna be jumping to the future, but I don't want to forget about HAL in 2001. Do you think there's, sometimes people talk about AI having hallucinations, and I know those are getting less frequent as we build better models. Could you share, if either of you knows whether we think those are going away? It's a fun topic. And then did the people who wrote 2001 actually know about hallucinations? Because HAL arguably got stuck in a moral, ethical dilemma and had some hallucination problems of its own.
So I think hallucinations are going down. They're not done yet. We've gotten better at catching hallucinations, is what we're seeing.
Yeah.
So when we catch a hallucination, we can have a large model recreate what it did and sort of steer the conversation.
Yeah, and you can think of these modern models as a combination of two modes. One is the LLM itself, which still has some tendency for hallucination, because fundamentally it's a next token prediction system. So even though you align it well, it still has that potential problem. But then if you wrap it with another layer, like a reasoning agent, suddenly, you are able to pick up these problems much quicker and self-correct. And it's this self-correction nature of these systems that you're seeing with the reasoning engines that has truly been impressive.
When you say self-correction agent, is that the same as like my conscious as a little person sitting on my shoulder watching what I'm doing, kind of?
It's in the deep learning, in the AI parlance, it's like, you're looking at different, you're producing multiple tokens, and you have to pick what's the next set of tokens. And if you can think of having a system that generates the tokens and a system that can evaluate it, in some sense, if the evaluator is really good at saying, hey, that answer, not that great, don't go down that path, pick this other one. So in a way, it's like your consciousness, but I think a little easier
Okay.
to put together.
I would say more like your parent.
Okay. So
Telling you, no.
disconnected. These systems have an air gap or something.
That's one implementation of it. One's a conscious and one's like someone telling you, is like, hey, this is wrong, redo it.
Right, because if it's your own conscience, maybe your own conscience still needs like the parent on top of that, right? Okay, cool. So we mentioned Roblox safety, and over the years we developed so many models: image, text, voice, handling moderation, and that's sitting there working in the background. And then in the last year or two, in addition to all these background systems that are doing all this hard work, now we've been exposed to generative systems. And I think we were all first exposed to text generation. We've seen that start to move to image generation, seen it start to move to music generation, sound impersonation generation, now video generation. And then what we're going to be talking about is 3D generation, and then ultimately interactive 3D generation. Is each of those steps harder, as we go down that road, as we think about it? Because it seems like text generation is getting more mature, but we're not all using Google Photos or Apple Photos to generate videos right now. So I'm wondering if as we go up that, it gets more difficult.
It's less about difficulty. I would say it's more about the maturity of the space and the number of people working on it and the data sets that are available to be able to train these large generative models. And in the sequence that you painted, from text to image to audio to 3D, I think the amount of data that you have to train these systems progressively goes down. So to build a foundation model that can actually produce 3D is substantially harder, because now you can't just rely on 3D data alone. You have to somehow plug it into another model that is trained on a different medium modality, right?
Yeah.
So that therein lies part of the challenge. But I would also say that the maturity of text NLP as a field that has delivered a lot of analysis tools to the community is also very helpful, because the transformer architecture came out of analysis, for classification of text, and also for transforming from one language to the other, right? So it's that modality where you have to analyze a sentence for some summarization or a classification task, and once that became mature, suddenly people tried, hey, what if we just do generation with it?
Yeah.
And so that, to some extent, that field has existed for a while, and some of the newer fields like 3D are just starting to build.
So you mentioned training data. So behind the scenes, when we think of all of these popular models, and I think of all the data, I think of, okay, what is all the text out there? There's every book that's ever been written. There's every scientific journal that's ever been written. There's all the web pages in the world. These are a lot of places where there's text. Is literally a lot of this data being used to train now? Like, are people being able to gather all that data?
Yeah, some of it is licensed, some of it is sort of open. But there's literature that has been digitized specifically so that models can be trained. This is also when you're doing task specific stuff to help a doctor and things like that. So a lot of this is human curated data that will help the LLM in a particular task that it's not doing well.
Got it. So that leads to, we're familiar with petabytes of text out there, video, maybe images, quite a few, videos not as much, but then interactive 3D data that's used for games and experiences, go to a concert, play hide and seek. That's a much more scarce type of data, I assume.
That's right. Yeah. So, you can put a number to it. If you look at the open source data sets for images, even though it's much smaller than text, it's in the hundreds of millions of images that have captions with them. So those are the things that you need to during the pre-training of these data, of these models. And for geometry, for 3D, the biggest data set out there is in a few million assets. So it's substantially smaller in number compared to images or video or text. So that makes the problem very uniquely challenging.
So that's really fun because Roblox has a lot of 3D data.
Correct.
And 3D data is needed to train up these models. And so let's lead into a bit of what we're hoping to be shipping in literally this quarter or next quarter. And one that's pretty straightforward is text gen as a service. We'll come back to that. But I'd like to jump straight to 3D as a service. Let's talk about that. Like, what are we thinking of shipping soon?
Imagine if we gave the creators an API that they can open up to users so that users can say that I want to create this podcast room. I want to have Dave sitting here talking to Kiran and Nishchaie. Rather than, and it makes every user a creator using that API. You can texture it a certain way. You can have Kiran and Nishchaie and Dave wear the same sweater. You can have, the chairs and tables look the same.
That's right. I think what you're almost saying for me is if we can imagine it and it seems possible, it's not like faster than light travel. This is just more better computer science. We should assume this is going to happen.
That is correct.
Someday.
Sort of realizing your imagination, your vision in 3D, both in terms of individual objects as well as the layout that captures the 3D-ness correctly is what we are working towards. And in terms of what we are shipping, it's pieces of the technology building up to the vision. So starting with the ability to generate a single object.
That's right.
And I think we have the object itself could be, right now you could start with props in the scene, and eventually this year we plan to release avatars, which are built with generative AI.
So now in the midst of it, we've all been working with the AI team over the last year talking about this. And one Roblox values decision we've had to make is, do we get this perfect? And like we want to go all the way to photorealistic 3D generation, and we're just going to keep it in the lab until we ship it. Or is it better to get feedback as quickly as possible on quality, performance, how people use it, even if it's slightly rougher, as long as it's safe, as long as it's copyright compliant? Can you share a little of kind of the decision making we've gone through around that?
Yeah, I can take a first crack at it. So yes, in the spirit of shipping a safe tool early and iterating on it, and getting feedback from the community, that's the ethos of the company at large, and I think that's what we hope to do in the AI group as well. And if you look at the AI community outside Roblox as well, that's the general style. People ship once it reaches a certain threshold, and then continue to iterate on improving the quality. That definitely fits into our mindset as well.
Yeah. I think even from an infrastructure side, right, get to production faster, we need to learn how to run these AI systems at scale. And we can't wait for systems to be close to AGI before we know how to run them. And as systems get progressively more complex, so will our infrastructure code.
In a way, we're keeping things in sync, right? Because in addition to the algorithms and all the training, we're running an AI platform.
Yep.
We need to know how any creator on Roblox can call these APIs in their experience, how they can get 3D objects back, how we can moderate them. So one of the nice things is you're going to be exercising AI platform in sync with some of the computer science.
Absolutely, and it's crucial to start from the start because we're also shipping we're shipping bare bone APIs. We're not giving hey creators do this with it. We also want to learn what creators will do, so we know on what modeling efforts to make them better.
So we've played with prototypes of this, and so when we take a step back, all of the creators on Roblox, they build 3D experiences. Those have APIs. We're going to launch an API. So if I'm walking around a 3D experience, I can type, we'll moderate it, build this 3D object, and that object's going to appear. It's absolutely amazing. I think when we did a demo a few weeks ago, I said I want a pirate wheel of a spaceship, of something or something.
Yeah.
And there it was. Like it looked pretty good to me.
Yeah, it's getting there.
Yeah.
Baby steps.
Okay.
Yeah, I think the big meta point here is that we want to open this general purpose object generation capability, and we want to open this to our creators in a way that will allow them to explore the user's creativity in populating these experiences, right? So it's now opens it allows the users of the platform experiences to generate things that they've never been able to do before, and and what they will do with it, as long as it's safe. We want the outputs to be compatible with the platform, and but then we want it to be free.
Right. So this is the mesh generation API. There's a little bit of a notion of Roblox here in that we believe by having unlimited 3D generation in the cloud for every game creator, there may be new classes of experiences and games we don't even know about because no games have ever had unlimited 3D generation as part of them. We're used to right now because we don't have it, we maybe have to decide what we're going to wear or pick items off a clothing wrap rather than defining them. So this is going to be really big. Behind the scenes, I'm sure it hasn't been that easy. Have there been any technical challenges or like we're building 3D generation? I'm curious what kind of technical things we've had to solve or figure out.
The key innovation, the key unlock here is our way of digitizing 3D that makes it compatible with LLMs.
Okay.
And so what you see in the community in geometry generation is people, especially in the academic community, are taking a particular route of generating geometry with diffusion models today using global latents. Mm-hmm. And that's totally fine if what you're trying to build is individual objects. But at Roblox, we want the ability to go from a single object creation to multi-object creation to multimodal creation. So you may want to actually allow add scripts to these objects that you've created. So by nature, it's both multimodal and multitask, right? So you want the ability to produce both shapes and text together, and that capability means that you want to bring it into a framework that is compatible with LLMs, which is multimodal LLMs. That's so, in some sense, aligning the problem to the multimodal LLM architecture was the big unlock. And there was no clear way of tokenizing geometry to be compatible with LLMs. And one of the things that we're going to talk about is our VQ-VAE architecture that tokenizes geometry and produces results that are
So if I go to some Silicon Valley cocktail party and say, yeah, we're tokenizing geometry to make it compatible with an LLM, would that be kind of cool and hip?
Yeah, imagine an LLM, you can give it a scene and ask it how many chairs are there, right? Similar to what you do with images. That's what this unlocks.
Yeah. Which I saw that demo and it was amazing.
Demo, yes.
Okay, so that's a huge unlock. I can remember many months ago when we were actually talking about how we're going to tokenize, and then I remember we hit on this and started seeing acceleration. How about on the platform side? So I know we have over 200 models running on our platform. Have we been able to get leverage, like use that same platform we use for safety, for training, for 3D as well? Like build on top of that?
We have, but this was a bigger challenge for us because this is a multi-GPU training cycle.
Yeah.
We were training on 2 GPUs, 8 GPUs, 10 GPUs, but how do you train on hundreds of GPUs to train this model? So that was a big challenge. We had to sort of redo some of our networking protocols, work on GPU utilization, figure out how to load data more, efficiently because, working with textual data and 3D data is very different.
Yeah.
A lot of work has gone into optimizing the inference of 3D, right? You don't want to sort of try and create a 3D object and wait for a minute while it appears. You want real-time editing capabilities. So how do you sort of use things like CUDA graphs and things like that to get your inference time within sort of sub 10 seconds, 5-second range? There's a lot of computer science that's going in there. It's a lot of fun too.
And optimizing inference is a very Roblox thing, right? On voice, for example, if we have millions of people all running through voice moderation, optimized inference means we can run efficiently
Correct.
all of those models. And so if we have millions of people generating 3D objects without optimized inference, like our system's probably going to blow a fuse or two.
Correct. And also the usability of the product will go down.
So faster response time.
Faster response times.
And this also goes back to the design decision of the architecture. By making it a next token prediction architecture,
That's right.
we are basically leveraging a lot of the innovations in the community that are being put towards text. So tokens, whether it's text or from shapes, it's going to be processed the same way. And so all the tricks, that the CUDA graph stuff and a lot of the other tricks that are in the community is directly usable for us as well.
Do either of you, we're going to jump from 3D gen to some other stuff, but do either of you have a particular use case you could imagine or you think about for 3D gen? So I'm imagining a medieval castle game where you define your own castle just by talking about it, for example, and two castles appear. Any favorites you?
I am thinking more on what sort of game mechanics this unlocks, right?
Okay.
Like, in the SimCity or sort of Second Life era, like how do I decorate my room? How is it easier to decorate my room? That power, that is the thing I'm thinking about. How do those games change?
Well, it might make it almost too easy to, right? Imagine I'm a 13-year-old living in the 1960s on the lower side of Michigan. Like, what's my room look like?
That's right. And it's this combination of both scene summarization understanding with scene generation. That's a unlock when for lots of game genres. And even for the experienced game developers, this gives you a mechanism to iterate very quickly. So you have an idea, you can prototype really, really quickly, and that is and then really focus on things, get the basic idea out, and then really focus on what would you add to get that extra oomph for your game.
Now we're starting with 3D mesh gen. If we go all the way to double black diamond, most difficult, start with 3D creation gen, which we're starting to think about. It's just with any prompt, generate a full 3D experience, a game, a concert stage, anything like that. Can you share a little of like, what's the difference between the single 3D part versus a full 3D interactive experience?
I think when you're thinking of a scene or sort of your medieval castle, etc.,
That's right.
it is made up of, say, tens or thousands of hundreds of objects.
Yeah.
All those objects have to share some characteristics with each other. The aesthetic needs to look right. The texture needs to look the same. The placement needs to happen. So the way that I think about it is that you have single object model that are creating objects.
Yeah.
There is texturing that makes sure that they look all sort of from the same era. There's a layout aspect to it so that the layout is coherent. There's a table and there are chairs around the table, and all of this is interactable.
That's right.
That's how I think about it.
If you look at actual game levels that people put together, there's a lot of cleverness in how they choose where to put detail versus what objects. Like for example, this table, they may just model it with a block, a CSG block in Roblox, for example, and maybe the plants behind you that's more meshes, or rocks have lots of meshes and things like that. So there is a lot of understanding of what primitive you use for a given object, and the ability for a system to automatically generate, hey, the table is made of parts, CSG parts, and the planter with trees are made out of meshes, and doing it seamlessly in a way that you can interact with it.
Yes.
is makes it very efficient for the platform as well.
Now let's go up the level of complexity from the table to a automobile. An automobile is more complicated than a table, right? An automobile has moving parts. It has wheels, axles, physics. And most automobiles that we work with when we're playing 3D interactive experiences, Usually you're able to drive them. They have a heads-up display. They have an instrument panel. Like, what's the difference between a table and a car in video experience land?
I think a table has no life,
That's
and
right.
and a car has life, and life comes with scripts,
Which is code.
which is code.
3D object with code.
Correct.
And real cars have engine computers with code running. Game cars have computers running too.
Correct.
Yeah.
And LLMs do one thing well, which is write code. And our architecture sort of supports on sort of when you create a car, can you attach a script to it
That's right.
to move it fast?
Yeah, and it's not, it's generating the script as well, right? So,
Yeah.
you're generating the parts and some, with a prop like a table, there's no script, but a car could automatically, when this works, it's work in progress yet, but it can segment the object into the wheels and the different components. And then the generative system can also generate the code along with it because it's inherently multimodal.
So that will be magic. Rather than a static sculpture of a car, build me a sports car, blah, blah, blah type of engine, modern, I'd like it to be blue, super sci-fi, and make it drivable at 200 miles an hour. Get a fully functional car you can hop in and drive around.
Yeah,
And you can give it a pirate wheel.
Yeah, with a pirate wheel.
Yeah.
the one thing, if you look at what's happening in the community today, and you can actually get code that simulates just the code part of that experience, right?
That's right.
But it cannot generate geometry. So it
That's right.
doesn't produce any geometry. And so the unlock with our models is that it can generate both geometry and code it's all tokenized together with the same framework. And the LLM knows, okay, this set of tokens decode out to geometry. These set of tokens decode out to code. These set of tokens decode out to CSG parts. And it's because it's just a text token prediction type of setup. So it's a sequence of tokens that represents the output that you care about. And the magic unlock when this all comes together is when you can sit in it and drive. Right?
That's right. So that was double black diamond. Let's go to triple black diamond, which is where I'm going to be gone for 15 minutes. But I'd like digital Dave to play with my friends for 15 minutes because I'm not going to be there. And this is also part of the sci-fi curriculum. That's also quite interesting, right? Because I've been playing Roblox a lot. I've texted a bunch. I've talked on Roblox. I have a certain way of moving around a room. And so that's all data maybe that someday could be used to build my digital twin in Roblox as well. So that's even a further stretch out. What's your thinking about that?
To me, that is another modality that we tokenize and put it into the system, right? So in a way, the framework is general purpose. You can for the behavioral pieces, it's 1D data, right?
Yeah.
So we know how to tokenize that. So in some sense, it's basically making sure that the challenges there, of course, are that it has to be relevant. It has to capture the nuances of digital Dave. And so the reconstruction requirements for that might be very different from maybe a prop. And then the interaction is another challenge, right? Like the tokens that decode out should interact with the geometry that's in the scene. So I think in some sense, what you're painting is a vision where there is a parallel version of what's happening in the scene, the data model and the behavior captured with tokens, and then you have the ability to jump between the two.
So now I'm going to ask you both to make a really difficult prediction, right? So there's a lot of sci-fi around people using their digital twin to help do things efficiently. And I think Black Mirror had an episode where digital twins go on 1,000 dates to figure out if there's compatibility quickly. Do you ever think that'll happen?
No.
Oh, I like it.
No. Not the dating aspect.
Okay.
That is too personal. But I do think that there is going to be a lot of sort of the way that you think, the way that might interact.
Yep. What do you think, Kiran?
Yeah, I'm not so sure if that's not going to happen. It's if you look at the trajectory of the music that comes out of AI systems, the ability for systems to clone people's voice and mannerisms, and the ability for systems to clone people's videos, right? And you can produce video of people that really are visual effects quality today. It seems
Yeah.
possible from a technical point of view.
My view on this is sometimes if we can imagine it happening technically as compute power increases, then we may be stuck where these things are going to happen, and then it turns it into, can it be done in a empathetic and elegant way rather than a dystopian way? And I think if we would have asked people 30 years ago, would you ever go online with some system to meet a future spouse? Everyone would say, no way, like that's impossible. Like they might have had the same reaction. So
I think
yeah,
mine is that I think technologically it'll happen. My
Yeah.
hope is that the personal touch doesn't go away.
I think that's right. So a lot of things I think are going to happen. Faster than light travel, we haven't seen the physics yet, but anything, for me at least, we can imagine from computational power, I think there's a chance it's going to happen. So 3D gen, avatar gen, doppelgang, all of that gen. Let's pop into another area around the whole AI wave and the open source community. We now have two models we've publicly talked about sharing. One is, once again, in a compliant way, we've built some of the best voice safety models in the world, and we've open sourced that on Hugging Face.
That's right.
And we're going to be open sourcing a 3D foundational model so people can create 3D stuff as well. Can you just tell people, like, what's up with the open source community? Why is it important? Why are we doing it? We could start with our voice model and then move to our 3D model.
Want to take a stab?
Yeah. So for the voice model, we built it on top of an open source framework. We started with WaveLM, which is an open source framework, and we were inspired by open source all along. And when it came to looking at the results from our trained from scratch version with the WaveLM architecture versus what's out there in the academic community, our results were way better and much more relevant to what's actually happening in the real world of voice toxicity. So we decided to open source it so that we set the bar correctly for the next generation of systems working on this problem. So that this way people are tackling the right set of challenges and making communities safe. So this was a way for us to pay back to the community. And in the same spirit, we are going to open source the tokenization module that unlocks 3D generation for the community as well. So we've chosen to go with a certain set of LLMs to bring 3D generation to our community. But I think by unlocking the tokenization to the larger AI community, people have the freedom to put together systems on their own. Like, for example, Lava is an example where multimodal capabilities came out from the open source very much quicker than many of the frontier labs, because some of the core modules were out there and people found out ways to combine them together.
I think a very cool outcome would be that one of the LLMs that we don't build has spatial reasoning that is built on top of the 3D tokenization that we release to people. That shows, cool. And then, the other way that I look at open source is that I feel that this is, it's a way for us to bring the 3D community together. 3D is not a space that has actually seen a lot of people come together, unlike the tech space, etc. People are sharing architectures, or people are also sharing their data sets, etc. This is an opportunity for us to say, hey, listen, we are doing this. If you have your proprietary data and you want to create based on your proprietary data, you can fine tune this model and make it do its bidding. So that part is very exciting to me.
I'm curious if either of you has any feedback on, with our voice model, in a way, there was an element of elegant necessity there. We knew people wanted to use voice in Roblox. We had many ways of throttling it. We could go a certain age, certain ID verification. And so we created an ecosystem where we literally couldn't turn it on for more people until we had enough AI at enough efficiency to run all of the voice. Did either of you pick up on that? Like, I thought it was very motivational, right? We had a giant brainstorming group. They were stuck in a room because it was almost like we can't turn voice on all the way until we build a good enough AI model. I thought it was kind of elegant, right? It's sitting there. We can turn it on for more people, but we need like the brain power of the AI system to support this efficiently. Did it feel that way, or did it actually just feel like, oh my gosh, what are we going to do?
No, it definitely felt that way. I was.
I think I was in that room stuck, so I could feel the, oh my God, how do we unlock this? This has to be solved correctly, and every other system that was doing voice moderation in the community was converting voice to text, and then doing text moderation, because that was a problem that we had solved and the community had solved. But our unlock was basically saying, hey, look, let's just directly use, do moderation classification on voice directly, and avoid that extra step. And the minute we took that decision, it essentially made a lot of paths clearer. It was a risk, but I think in some sense that's what made it successful.
The one anecdote I'll share from there is that every other project I've been a part of, the compute requirements kept going up as the project went forward. Unlike voice, where the compute requirements kept going down, which made the project just more tractable. It's a very Roblox way of doing things.
Yeah, because we might still have voice for 18 plus ID verified, like a very small set, without running that model in the background.
And it was also an example where releasing early, getting some data from the real world really made that loop very, very critical. So the lessons learned from that project, even though it was not generative, it was
so that even makes it for me more exciting that we're open sourcing the results of that for the community. We really did stumble on something really good because of necessity, in a way. So hey, behind the scenes, as part of this AI system, there's a bunch of other components that are interesting and hovering in the background. We talked about 3D mesh gen. But we didn't talk as much about a bunch of other components: text generation, text to speech, speech to text, language translation, safety. For me, those are exciting because when I imagine putting all of those pieces together, it feels like a toolbox for creators. And I want to see the first creator to talk to your favorite historical character safely, whoever it may be. Can you talk a little about those? And I'm assuming such a thing's going to be possible.
Yeah. So, coming back to your doppelganger Dave example, there are two options. I can give an API for people to create doppelgangers. We took a different approach. We'll give you very basic APIs.
That's right.
We'll give you a text generation API, a text to voice, voice to text, and you can stitch it all together to create your version of digital Dave.
That's right.
And it's very interesting, right? Like when we started working and thinking about giving text generation APIs, we asked ourselves, I'm like, hey, listen, how will we do a better job compared to everyone else out there? Why are we doing this? And the answer was twofold. No one's going to generate text that fits our safety policy on the platform. And, because we control the user experience, we can just do it more efficiently. So that's how we sort of started building the text generation service. And similar to sort of, taking a lot of learnings from our voice safety system, can we do a text to speech and a speech to text system model, all built on top of open source that we can open up to creators.
It's very exciting.
In many ways, that toolbox that you mentioned is the key. Having access to all the different pieces that makes the final experience, some of which requires the extra Roblox sauce, and some of which can be more open source models out there. But I think having all of them available and being able to string them together allows us to see how people use these capabilities. And if we choose to double down on something, that's based on user feedback.
I mean, there's just a good hygiene there, right? Good game engines ultimately have separated DLLs. Good websites ultimately have microservices talking to each other. Yeah. It seems like a good virtual doppelganger should be built up of various components, each of which can be swapped in, replaced, tuned independently rather than doppelganger monolith to the extent possible.
100%. We don't want to decide for people what and how they want to build it.
I mean, the challenge though is again, if the latency requirements are critical, right? So those are sort of infra challenges that we'll have to solve depending on the usage patterns. If people land up hitting, unreasonably slow, issues, then and those are the things that the engineering can focus on.
So where do we think this all goes in 5 to 10 years? Do we still think there's game developers? I'm personally an optimist. I think this is, for me, I've been saying this is no different than moving from oil painting to Photoshop. These are human acceleration tools. Do you think that's the case, or do you think game creation will disappear?
One of the main motivations for embarking on some of these AI-generated worlds and 3D is to allow non-experts to be able to start the journey of creation.
Yeah.
And it sort of lowers the bar for people to experience the magic of creation, and that is going to improve the funnel, like make the funnel much bigger. And so you're still going to have the really creative experiences that are going to stand out. But for people who are just interested in experiencing building 3D, this is an unlock, right? So in a way, you are bringing more creators into the platform by opening up these tools. So it's not that it reduces the creativity on the platform or the need for creativity, but it's just that more people are now on the platform doing interesting things.
Yeah, it's interesting to think if a long time ago we all used to do multiplication by hand, and then we all learned how to use scientific calculators. It's interesting to think if that we're going to see that same thing with AI, and more young people are going to learn prompt engineering and learn to use these tools very effectively, side by side traditional ways of creation.
Yeah, and I think one other thing that is really interesting is, imagine you have an AI system produce content for you, maybe meshes, in this case. You as a student learning how to do modeling, you might actually look at the outputs from these systems which mimic the experts, and so your learning curve is also going to be much faster because you're looking at the outputs that are looking legitimately expert created, and that makes you want to know, this is why the table needs to be made of CSG versus the plants need to be made of meshes. And so it also really helps kids and the people getting into the platform to learn the right ways of doing. It's not just about producing code or producing meshes. It's also the right way of setting it up so that it actually works together as a successful experience.
I also think about the example that you shared when the combustion engines, etc., were coming up. And I think, people who drove horse carriages learned how to drive cars.
That's right.
And I think the same thing is going to happen, how, AI is going to sort of turbocharge their workflows. And those workflows will change eventually. But to begin with, it'll just be an accelerate.
Okay, well, that's a very optimistic view of AI from the 3-person panel. We're all thinking human acceleration, not human replacement. And one big takeaway is the criticality of data and how data can accelerate AI training. So wonderful to have you both on today. It's been really exciting. I think our audience is going to learn a lot from this.
Thank you, Dave.
Thank you.
Okay, Nishchaie, Kiran, thanks a lot. Okay, hey, this has been another episode of Tech Talks with Dave Baszucki. Stay tuned for our next episode coming in a few weeks. Thanks.